spanning tree protocol. So, what is meant by spanning tree protocol? So, we discuss about that exercise. Let us have some basic theory portion for part of this particular one. So, the spanning tree protocol means it is a protocol which is used in a switch to create a loop-free topology. So, it is going to create a loop-free topology. So, what is meant by loop-free topology? Assume that you have a structure like this. So, some number of switches are there, switch 1, switch 2, and switch 3, and you have PC1 and PC2 as well as, in case if you want it, you can connect them all. Fine. Now, I want to send the data from PC1 to PC2, but I don't know the physical address of this particular PC2. So, what I have to do? Usually, I will use the protocol called ARP broadcasting. By using this ARP broadcasting, I can able to find out the destination address of this particular. So, by getting this destination address only, I can send the data from PC1 to PC2. This will be done using ARP mechanism. Okay. So, while ARP mechanism is trying to perform that, trying to find out the MAC address using ARP broadcasting, what is happening? First, the ARP broadcast will be forwarded to switch number 1. Now, what this switch 1 will do? This will broadcast this ARP broadcasting to switch number 2 as well as switch number 2. Okay. Now, switch 2 has received the broadcasting, so it will be broadcast into switch number 3 as well as PC number 2. Likewise, the switch 3 also have received the broadcasting, so it will send the broadcasting to the next one, what the link I have. Now, switch 2 have received this one, so I will send back to this one as well as here is also. And this switch 3 has received the same broadcasting, I will forward this. So this process will be repeated again and again and again, which will create a loop. So I want to avoid this particular looping process, because if you keep on sending this broadcast again and again and again, it is going to create a heavy traffic and also a loop also. So we have to avoid this particular loop process. So to avoid this loop, I am using the protocol called STP, which is called the spanning tree protocol. Fine. Now you might have understood what is meant by the spanning tree protocol. Why should I use the spanning tree protocol? Fine. Before we discuss about the spanning tree protocol, we have to know about some of the important terms. The first one is root. So what is meant by root? It is a centralized switch which decides the best route to send the data, so that all the packets will be forwarded through that route. In this scenario, I want to send the data from here to here. So what are the possible paths are available? I can go in this path, or I can go in this. So there are two paths which are available with me. Okay, so PC0, switch 0, switch 2, and switch 1 and PC1, and in this path also I can follow. So which path will be selected? Which path will be selected? So out of these two paths, any one path will be selected as the best path. So this can be identified, this can be selected by a switch called root switch. Okay, so it is a centralized switch which decides the best route. Fine. So here I have connected 3 number of switches. Among the 3 switches, which switch will be selected as a root bridge? Okay. So to select the root bridge, first and foremost thing is we have to select the priority line. Before we discuss about it, let me draw the diagram first. Network structure will be created, then we will discuss. I will. Fine. Now all the switches are connected. They have to be, initially it is in orange color, then they will become green color. The color started changing. If you look at this one, all the lines are in green color except for this particular. What does that meaning? Once you here, by disabling this particular port as blocking port, this port is called as blocking port. This is in orange color, which means what? It is not forwarding any packet. So by disabling this particular port, I could able to avoid the loop. For example, if I am sending the broadcasting here to this one, this port cannot forward. If I am sending the broadcasting to this one, and this cannot forward to the next one. By this way, you can able to avoid the looping process. Now we are discussing about root bridge. So how to identify the root bridge and what is the process to identify the root bridge? So span. once you type the spanning tree, show spanning tree command, you can find the list of interfaces FA0/2, 0/3, 0/1 for this particular switch. All the routes will be of designated port. Designated in the sense I can able to forward it. It is in forward state. Okay, the cost we will discuss it. And okay, next let me open this one. So, it is also it will list out the status of this. These two ports are designated port, and FA0/2 is considered as root port. And in this particular switch, switch number 2, FA0/1 is considered as root port, and this particular port is in block state. FA0/2 is in block state. The remaining ports are forward. Now we will discuss how to select the root. How to select the root. To select the root bridge, what are the conditions? First, we have to compare the priority value. Each and every switch will have a priority value. By default, the number is 32,768. So, if the priority value is very small in the sense, that particular switch will be considered as a root switch. We have three number of switches. Out of these three switches, which switch is having the lowest priority value? Which switch is having the lowest priority value? That switch will be selected as a root switch. Okay. Let us check each and every switch priority value. Let me show each and every switch. Parallel let me. Okay. Now we will check what is the priority value. Here it specifies the bridge ID. Okay, the number is 32,769. Here is also 32,769. Here is also 32,769. So all the three switches are having the same priority value as 32,769. By default, the value is 32,768 plus 1. Plus 1 in the sense your VLAN is 1. VLAN 1. So 32,768 plus 1. So it is 32,769. So all the switches are having the same value. All the switches are having the same value. So you cannot use the first option to select the root bridge. Now, if the priority value is same for all the switches, what I have to do? We have to look at for the lowest MAC address of the particular switch. So here, let me try to find out what is the lowest MAC address. What is the MAC address of each of the switches? What is the MAC address of each of the switches? In this one, 00E0. In this one, 0006. In this one, 0002. So by comparing these three switches, this particular switch is having the lowest MAC. So this switch 0 has been selected as a root. How to check it? Let's look at this. This bridge is the root. This bridge is the root. Okay. In that switch detail itself, show spanning tree. This bridge is a root. If you look at the other switches, such details are not there. Okay, no such details are there. For switch number 2, and if you look at the switch number 1 also, no such data, no such information is there. This bridge is root. It is not available. So this particular switch 0 is being selected as a root switch. So this switch is a root. This switch is my root bridge. Okay. Now we have identified this particular switch as a root bridge, and through that root bridge, the packets are being forwarded. Whatever the data which is sent in this particular network will be forwarded. Suppose if I am sending the packet from here to here, PC1 to the server in the sense, the data has to forward to this particular port. It has to follow this particular port only. If I am sending from here in bits, it has to follow this port only. If any response is coming from this server to any of the switches means it has to come to this particular port 1. Okay, next. The next terminology is root port. It is a physical port of the switch which is connected to the shortest path to reach the root. It is also called as designated. Okay. So the root port in the sense, the root port of the switch is connected to the shortest path. So simply we can call it as, this is my root bridge. This particular root bridge is connected with various number of switches, and this port is considered as a root port. Okay, the port which are connected to the root bridges are called as root port. FA0/2 is the root port for this particular switch. FA0/1 is the root port for this particular switch. Okay. How to select this? There are some rules, and shortly we have called as identified. So first and foremost thing is you have to calculate the forecast. You have to calculate the forecast. What does mean by forecast? Forecast in the sense the bandwidth of each of the connecting line. In case if it is a 20 Mbps connection, the cost will be 10. If it is 100 Mbps means, for example, fast Ethernet means the cost value is 90. If you are using 1 Gbps connection means that is cost will be 4. If you are using 20 Gbps, means the class value is. So how to identify? If you open that whole spanning tree data, here the cost is specified 19, 19, 19. Okay. If you look at the other switch, the cost is also remains the same. Why? Because all the switches are connected to fast Ethernet. All the switches are connected to fast Ethernet connection. If you look at this one, port number, look at the ports. Fast Ethernet 0/1, fast Ethernet 0/2, fast Ethernet 0/2. So all the ports will be of fast Ethernet port. So for fast Ethernet port, the speed is 100 Mbps, so the cost will be 9. Okay, hope you understand what is the port cost of this. In case if you are using gigabit Ethernet connection, the cost will be. If you look at this one, all the switches are in the same path cost, so I cannot use the first option. So what I have to do, I should go for the next option, check for the bridge ID. What is the bridge ID? It is a combination of both priority value as well as the MAC address. Okay, so priority value is also same for all the three switches. So I should go with MAC address. If you are adding these two values, automatically the switch with the lowest MAC address will be considered as a root. Okay, so in this logic, these two ports will be identified. In that case also, if both the values are same, in what case it is going to be same? Because each and every MAC address are unique. I will give you another scenario. If I connect like this, what will happen? For all the switches, the MAC address remains the same. For this line also and this line also, the MAC address remains the same. The MAC address remains the same. So I cannot apply this particular logic. I cannot apply this particular logic. So in that case, I should go for the next one, lowest forwarding physical port number. Lowest forwarding physical port number. In this scenario, what is happening? This is connected in FA0/3. The other line is connected in FA0/4 or 0/6. So which one is having the lowest value? This is connected in 0/3. The other one is connected in 0/5 or 0/6. So 0/3 is the lowest port connection. So this will be set. So by this method, you can choose the route. Okay, fine. So these are the basic concepts, theory concepts related to the spanning tree. Now let me show you how your packets are moving from this PC to this PC to this. Let me show you with a simple scenario. I don't need any protocols, just ARP and IC. So this is my source, this is my destination. So have no function. What is the function? And it's what happened. No function. Okay. Sorry. Functional code in the sense not here. This is 10.0.0.1. This is 10.0.0.2. And it's not assigned IP address. This 10.0.0. Now we start. So source, the destination. Let me start the simulation. How the packets are moving, whether this path is going to be followed or this path is going to be followed. It is going to the switch number 0, then it goes to switch number 1. Both it is broadcasting. After this, The packets are not being forwarded. So it follows this particular path. It's coming back and it follows this path. So now on what? How the packets are going to be forwarded? This path will be selected. This path will be selected. Okay. So now what I'm going to do, I'm going to change the path. If I want to change in this, how you can able to change it. I don't want this path. I want to go. My packet has to be forwarded to this particular path. How to do this? How to do this? Okay. Fine. Back to this. So I want to, if you want to move the packet from this path to this path to this path to this path to this, the root bridge has to be changed. Okay. So now what I'm going to do, I'm going to change my root bridge from this switch to this switch to this switch. So how to do this? Open that, enable, scanning tree, nothing is there. Okay. So what I'm going to do, I'm going to configure. So what I'm going to do, scanning tree, config terminal, scanning tree, VLAN. VLAN is 1, give question mark. Okay. So there are two options. One is priority, the other one is root. This root is very, very simple. So let me go with root option. Then I will tell you that other one also. Root, question mark, whether it is primary or secondary. PRIMAR. This is the only command you have to use it. Before that, let me pick it. Let me to show you how it is running. 10.0.0. You are getting picking from -T. Keep jumping. Now let me enter this command. So parallel edition. So once you enter this command, the reply will be stopped because the connection is terminated. Look at this request timer. Look at the figure. Look at the figure. This path is also blocked. This path is also blocked. So automatically, this particular switch will be assigned as a root bridge. Then automatically this link will be enabled. For this request timer. Now the link becomes green color. So reply from this particular link. Okay. So I will show you whether it is going through this particular path. Let me go to the simulation part. Source, destination, play. Now the packet will be followed this particular path. Yeah, this is a root. So by this way, your packets are being forwarded, and how you can able to reroute the path from one path to another path by using spanning tree protocol. How you can able to reroute the path from one path to another path by using spanning tree protocol. Fine. This is one mechanism. And you can do the same in another mechanism also. You can do the same in another mechanism also. So what you can do, what is the other option? I can disable the port. I can disable the port. For example, I want to, this is the path which is selected. This is the path which is selected. If I disable this particular port, FA0/3, automatically this path will be identified and this switch will be identified as a root. Okay. So I told you, okay, this path will be identified as a root. So now I am going to disable FA0/3. By disabling this, how my packets are going to be forwarded. Show spanning tree, and look at this FA0/3 is your root port. This root port has to be disabled. Surface config terminal surface FA0/. Okay. Now I am going to disable this particular port. If I disable this particular port, what is the command I have to go to? SHUT. SHUT. Once I disable this particular port, what is going to happen in the sense? The pinging will be stopped. Look at this request timeout. Pinging will be stopped. Okay, so this port will also be disabled, so no packet forwarding can happen. So this root will be trying to identify the root bridge. So this will be selected as a root bridge, and this path will be identified. Take some time. Now it becomes green color and you will get the response. Yes. Now you check whether this particular port is root bridge or not. Check this one. Show spanning tree. This is root bridge or not. Here it is a root bridge. Packets are going to this path and coming back. This path is going to this path and coming back. So, path that. Okay. So this port is this one. So these are the two possible options you can use to change the path from one path to another. Thank you.